Um, Hello everyone. So today I'm going to talk about our ocean engineering proposal project. So we are willing to work on ocean monitoring using marine animals. So as you know, human activities are threatening the well-being of the world's oceans. Because with the global warming, we have problems such as the melting of the polar ice, coral reef bleaching, pollution of the ocean. So it causes a lot of alteration in ocean chemistry, and it threatens many species of marine animals. So in order to ensure that the world's ocean remains healthy and productive, it requires a comprehensive understanding of their physics, biology, and how they are changing. So in order to find an effective way of controlling and reducing these environmental problems, scientists need to collect various data of the ocean all around the world. So right now, the technology that are used to collect data are the ships of opportunity that take samples of the water all around the world, and also drifter and buoys to get data. So the what they measure mainly is the color of the water with cameras, the surface temperature, topography, vector winds, and salinity. But right now, a new solution is being explored. It's marine animals carrying oceanographic sensors. It's a realistic solution to many of the issues, because, for instance, the boats, they struggle to break the ice in the polar area. So animals could be a really good solution because they can go to these fully sampled regions. They swim multiple kilometers per day through the depths of the ocean. So it would provide biological and physical electronic sensors, long-term data streams on key marine environmental variables, hydrography, animal behavior, and ecology. So one main project has started to work on this use of animals. So the Global Ocean Observing System, which is a global system for sustained observation of the ocean, created in 2020 the ANIBUS project, which means animal-borne ocean sensors. And their goal is to provide freely available oceanographic measurements across the world's oceans, using animals, just as I explained before. And in addition to position, behavior, temperature, and salinity, animal platforms could collect essential biochemistry data and ecological information. So, so electronic tags would be attached to marine animals with integrated miniaturized temperature and conductivity sensors. So it would improve the capacity of ocean observing by sampling extreme environments, like, for instance, the Antarctic, as I explained before, during the winter, or more of the tropical oceans. So right now, animal-borne sensors are collecting and transmitting in near real time an average of 500 temperatures, salinity, depth profile per animal annually. And it's getting a lot of attention from the ocean community because its deployment on a large scale requires international cooperation to deploy the sensors and later to collect, analyze the vast amount of generated data. So our project for this semester is to improve this animal project, because even if the use of this system, the use of this system is relatively new, so it's still limited, and a lot of areas are undersampled. Like you can see on the map, in blue, all of the areas that are undersampled. So it's very challenging to observe polar seas, coastal shelves, wet tropical oceans, and deep ocean. So filling this gap is pretty crucial. And we believe that some attention to other research areas that has already been made should be paid attention, and that a lot of different species should be considered, because right now the ANIBUS project mainly focuses on these 3 species that are turtle, penguins, and seals. And they mainly work with seals because they are very large animals that can be easily captured. You can attach also easily the sensor, and the recovery is fine. So it will cause minimal stress or discomfort to the animal. So we think that to fill the data gap, we need to study new areas with new animals. So for this project, we're willing to work mainly on these 4 areas: the polar seas, the shallow seas, the surface waves, and the deep oceans, and to study which animal would be best suited for these areas. So the first area is the shallow seas, and the main problem in this area is coral bleaching, which is a process when corals become white due to various stress factors. Because actually, when there is a stress factor, a photosynthetic algae begins to produce reactive oxygen species that are toxic to coral. So the coral tries to expel the algae. And this is a big problem because then the coral lose his food income and also his protection. So our proposal is to use animals to measure key markers for reef environments. And like these 5 key markers are stress factors for coral. So it's temperature, water, pH, solar irradiance, nitrate, phosphate, and salinity. And this would be the potential candidate that we could use because this is animals pretty high on the food chain that live in coastal reefs. For the second area, we are willing to work on surface waves with migrating birds because right now sensors are currently used that are VHF and UHF, but they need to be turned on and located manually. So it's very hard to get data because it has to be manually. And we found that a project called Icarus is developing sensors that do not need to be turned on manually, so that could be attached to flying birds. Right now, they use it just to track the migration of the birds, but our proposal is to use both of this project to analyze the wind speed and orientation, the visual aspect of the ocean, and the interaction of the atmosphere with the water. And we looked for some species of birds that fly over the sea, but also deep dive in the sea, so we could have some water data. The third area is the polar seas. So, because together with temperature, salinity controls the density of seawater and the flow of deep ocean currents from the tropic to the poles. And because of the global warming, the icebergs are melting, and icebergs are basically fresh water. So its melting reduces the salinity of the water and therefore changes a lot of currents because all of the oceans are interconnected. And here, this is a map of the sea surface salinity, and you can see that in the poles, we don't really have any information. So our proposal is to use ANIBOS to explore the polar seas to measure temperature, salinity, water pH, and nutrients using animals that live in this area. So we're going to study the Antarctic and Arctic food chain to find which animals would be best suited according to the different months of the year. And the final area we want to study is the deep water because of humans have a huge impact on the deep water because we are working more and more on the deep water. Here you can find all human activities. And also on this map, you can see how much deep water represents in the world. So our proposal is to measure temperature, water pH, pressure, dissolved oxygen, salinity using some species of animals that really dive in the deep water. But we need to work a bit more on that because right now we've only found animals that go to 3,000 meters and deep water goes even deeper. So our goals for this project is to first explore different animal species that are best suited for 4 different key regions in order to provide environmental data. Then we want to create a decision matrix for the 4 selected regions and corresponding animal species to select which one would be the best interesting to develop further. And then, so the one we've picked, we want to design a comprehensive system. And we have some additional goals. It would be to study a potential application in other fields of what we've worked on, because we focused mainly on environmental issues. And finally, design an alarm system taking advantage of the fact that the ocean is interconnected via oceanic currents to notify some areas of environmental issues. So this schedule, for the first presentation, we brainstorm, pick a subject, define the objective, and allocate the task. For the midterm presentation, we need to develop the researches on each region to present to the group in order to make a decision matrix and to decide which region we want to focus on. And for the final presentation, we will design the comprehensive system and study the additional goals. So for the job allocation, since we are 4 in our team and we study 4 different regions, we decided to pick, each one should pick a region. So I'm going to work on the polar seas, Lugabin is going to work on the shallow seas, Isengyu on the deep waters, and Shorefish on the surface waves. So these are our references for this presentation. And that's it for my presentation of the subject. So we prepared maybe a few questions in order to discuss with you about the project. So you can feel free to answer whichever inspires you.
I just have a question for the deep water fish.
Mm-hmm.
How are you going to manage to capture them and to be able to get the data from them? Because from the animal, I know like deep water fish stay in the deep water.
Mm-hmm.
They don't go on the surface, so you can't really get the data from satellites or stuff like that. So have you a thought about that or?
Yeah. Yeah, actually that problem makes me make my head big. So please show my slides.
Next one.
Next one, yeah. So we just prepared some fishes and whale and mammal, diving mammals. So we suggested just fish and mammals and some seals. So I'm finding animals to help for that problem.
Okay.
So I'm searching now. So yeah.
We know that is
next presentation. I hope I can present about the animal to help us.
Okay.
Actually, like Cindy also talked about how we could use some whale species since they can't dive deeper than 3,000 meters.
Yeah.
But he also talked about how we can use their ultrasonic waves to kind of scan deeper topographies, since like they have like their high like frequency waves. So maybe that could be a kind of solution. And since they are like mammals, they will
They go to the
water,
surface
yeah.
too. Right.
Yeah, I have a question. Are you have a plan for the development of the multifunctional sensors? I think you guys want to check about many conditions like pH and temperature and salinity and so on. So I think the sensor must be small enough to not harm the animals. So I think the development of multifunctional sensor is quite hard. So are you considering about this or just not for this scopes?
I think we'll have to study what's best because we could find a compromise, maybe like putting some sensors to some animals that just do like, for instance, water and salinity, and take other animals, maybe from the same species, but like to do other like other sensors. Or we have to study the sensors to see which one is what would be the size, which animal could carry that sensor or not, and then maybe divide between the animals.
So basically the plan is to using the conventional sensors.
Mhm.
I knew that there is a similar project from KAIST. They tried to attach the sensor to the bird in KAIST, and then they got some information about this kind of similar things about the atmosphere because it's a bird. So maybe I think you guys need to check you guys can we get some more information? And yeah, the kind of things from that research.
My comment is that the topic is very good. My concern, my worry is the problem is too big for your team. So my suggestion is you may need to focus down to say, we already know that there are 4 big areas of that already existing project. You may choose one of them and then go that more deeper then, because this big problem, each one has one subdivision, then the depth should be shallow at the end, right? My suggestion, you can choose one down and then go deeper. Also, just measuring some 4 parameters. My suggestion, you may select one problem to be solved by monitoring. So that then you can get more down to the deeper solution.
Our plan is we present design metrics for midterm presentation, and from midterm to final presentation, we will focus on 1 or 2 systems. So that is our plans. So could we follow our plan?
Right, but see, after midterm, you may be more busier than now.
Yeah.
That is usual case, right? So I
Okay.
hope you can get faster than that schedule.
Okay.
Find out, focus down earlier.
Okay.